Hello class, in this video we're going to talk about percentages of increasing and decreasing and as it pertains to growth or decay of, it could be anything, money, products promoted by a business, and you'll see those in the problem. So our real quick opener is we've got, sorry about that. We got 25%. We're reviewing how to convert from a percent to a decimal because that's going to be very big today. So move it over 1, 2. This is 0.25. Okay. Next, we are dealing with 42.6. This already has the decimal written in it. So I'll go ahead and move it over. 0. Ooh, that's an ugly 0. 0.426. And then moving it over 2 places to the left. You can have percents, especially when you're talking about growth and technically decay. 1.1235. I was going to say you can have percents over 100 when you're talking, like when people say, "Oh, I'm going to give 110%," but that's, you can only give the effort that your body is allowing you to output. But when you're talking about growing something, you can grow it more than 100%. Okay. So here we have the value of a home sold by Tom this year is $203,500, which is 10% more than last year's value. Find the value at the home last year. So there's a couple things we have to focus on. We have to focus on the percentage. Okay. And we have to recognize that it's more. Okay. So this is where we have to consider, and I'll show the work up here, that 10% more means we started off with 100% of something. In this case, the price of the house. Okay. Then we added 10% growth. Okay. So this would give me a growth. This would give me 110%. Okay. 110%. Now, again, if we're working on converting that to a decimal, because again, that's going to be a common thing, we're going to get a 1.1. So this is going to be the decimal we're going to be working with. We always want to remember this step, because if we just take 10% more and work with the decimal 0.1, we have additional work we need to do. Now, there's a kind of a general equation that we can work with and then fine tune it from there. We want to find the value of the home last year. So the value of the home last year is the thing that grew 10%. So value last year, and then we're going to multiply it by the percent, or in the decimal representation of the percent, to get the current value. Okay. That's how this works. Well, we don't know what the value was last year. That's what we're solving for. So we can just put in an X for now. And then the percent, well, we already did that work up here. And this is going to be quite common. You look for the percent more, you add that, and then you move your decimal place over. So that's times 1.1. So I'll write it as a more traditional equation, 1.1x. Okay. And then this equals the current value that we have is $203,500. Okay, so we have our equation, 1.1x equals $203,500. And this becomes an equation we've solved for dozens of times. We divide by 1.1. And we're going to get a value of 185,000. So 185,000. Now, let's just take a second to appreciate the simplicity of this. When something grows at, well, whatever percentage, in this case 10%, typically what we're left to do is multiply by the decimal of the percentage, so 0.1, and then add that back to get our current value. But we were given the current value. So by taking that and adding it to 100%, we make our life a lot simpler. So this is going to be the process from here on out. Okay, so a total sales at office products this year are $713,340, which is 35% more than last year's sales. What is the amount of last year's sales? So we, again, are going to take 35% and we're going to add that to 100%. Okay? So 100. And this part you don't necessarily always need to write down. This is just the thought process. And then we move our decimal place over 2 to get 1.35. So I'll write the formula down one more. It was last year's sales times the percent equals current. I'll just say current sales. Okay, great. So last year's sale, again, we don't know what that is. That's X. And our percent as a decimal is 1.35. And we got $713,340 in current sales. So we're going to divide by our 1.35. 1.35. And we get a total of $528,400. So $528,400. Okay. Due to an increase in demand for patented processes that will help the analysis of DNA of mice, Biotics Genome has increased production of testing kits for 20% per year for each of the past 2 years. This year's production is 93,600 kits. Find the number of kits that produced 2 years ago. So we can do this in 2 steps. So last year's times our percent is equal to 93,600. Let's think about our decimal. We're taking the 100, we're adding 20, that's 120. So we're going to get 1.2x equals 93,600. Divide by 1.2. Divide by 1.2. 93,600 divided by 1.2 is 78,000. Now, that is not our final answer because, again, it wants how many production kits were produced 2 years ago. And this is where we can just repeat the same process and do it another time. So we got last year's percentages. So 2 years ago, which would just be another X, and it's still increased 20%, equals 78,000 divided by 1.2, and we get 65,000. There we go, 65,000. Now, that's not unreasonable to do. That's okay. But we have to consider the possibility. What happens if we increase 20% per year and they want to know what our production was 20 years ago? Are we going to want to do that process 20 times? And the answer is no. So what you could do in this case, and this is a lot faster, is get your decimal. So I'll write that out real quickly. 120, and then move the decimal over. So you get 1.2. And then what you do to get your decimal is you get 1.2. Since we know we need to do it 2 years and multiply it by 1.2. And what you should get is 1.44. And you'll notice if we use 1.44 as our decimal and use 93,600, pardon me, from the current time to get 2 years ago, we divide by 1.44. Okay, and you get x equals 65,000 still. So there's a way to do it in one step. Now, there's nothing wrong with doing it recursively. That's up to you. But again, if we wanted to do it quickly and in one step, this would be your method. Due to a large gift from a donor, Blaylock College has increased the number of scholarships by 10% per year for each of the past 2 years. Of 1,815 scholarships being offered this year, find the number offered 2 years ago. So we have a 10% increase. That means our decimal is 1.1. We've seen this before. 1.1. And we want to multiply by 1.1. Oops, sorry. Let me clean that up. Since we got 1.1, and we're doing 2 years, we're going to multiply by 1.1, and you should get 1.21. Okay? So 1.21 x equals 1,815 divided by the 1.21 divided by 1.21. So 1,815 divided by 1.21 is 1,500. So x equals 1,500. After Nike deducted 10% from the price of a pair of competition running shoes, Katie Small paid $135. What was the original price? So now the main difference here is that the price was deducted. Okay, so let's underline that. That's deducted. So when we set up our decimal, we're not going to do 100 plus 10. We're going to do 100 minus 10. And that gives you 90. And then so our decimal is 0.9. Okay. So now when we set up our equation, it's just 0.9 x equals 135. We'll divide by 0.9. Divide by 0.9. So 135 divided by 0.9 is $150. So x equals $150. A 65-inch HD LCD TV is discounted 25% from the original price. If the discounted price is $1,799.90, what is the original price of the television? So discounted, again, we'll subtract. So 100 minus 25. That's 75. And then move the decimal place over 2. So 0.75. So 0.75 x equals 1799.9 divided by 0.75. Divide by 0.75. $1,799.90 divided by 0.75. Remember, this is money we're talking about, so we'll round to the nearest hundredth is $2,399.87. Okay. Go ahead, give the exit ticket a try. Thanks for watching.